Good morning, students. This is Professor Kiran Poddar, Angadi Institute of Technology and Management, Belagavi. In this class, we are going to discuss a convolution. Let us know what is the meaning of convolution and how it works between two functions. Let us move with the definition. The definition says the convolution of two functions f of t and g of t, which will be denoted by f of t star g of t. This star indicates a convolution between f of t and g of t, and it will be defined as f of t star g of t means a convolution between f of t and g of t is equal to integration of f of u into g of t minus u with respect to u, where u is 0 to infinity. This is the definition of a convolution, and it works between two functions like this with the help of integral equations. There is a property for this convolution function. Convolution, it says that a convolution between f of t and g of t will be equal to a convolution between g of t and f of t. Means if you take f of t as a first function and g of t as a second function, the convolution between these two, and if you calculate the convolution of g of t and f of t, means f of g of t is the first one and f of t is the second one, then also the result between these two will remain same. It is something like a plus b is equal to b plus a. Then we have an important theorem which provides a relation between two functions through a convolution, and this theorem provides a result to obtain inverse Laplace transformation of two functions which are bounded by convolution theorem. The statement of this theorem says if Laplace inverse of f bar of s is treated as f of t and Laplace inverse of g bar of s is treated as g of t, then Laplace inverse of f bar of s into g bar of s. Okay, Laplace inverse of f bar of s into g bar of s, Laplace inverse of these two product is equal to integration of f of u into g of t minus u with respect to u between the value of u 0 to t. This is the statement of convolution theorem. The convolution theorem will help you to find out the product of Laplace transformations and its inverse. Okay, if you take the definition as equation number 1 and the convolution theorem result as equation number 2, you can see the RHS of both are same. Here also it is integration of f of u g of t minus u with respect to u between 0 to infinity. The same thing we can obtain here also. When these two things are compared, these two results are compared, then RHS will be equating to second equation of RHS. Therefore, we can equate LHS. Therefore, f of t star g of t means the convolution between f of t and g of t will be equal to Laplace inverse of f bar of s into g bar of s. Fine. Or else if we send this Laplace inverse to the other end, from these two equations we got this result. If this Laplace inverse is been taken to other end, then it becomes Laplace transform. Therefore, a Laplace transform of f of t star g of t is equal to f bar of s into g bar of s. Means this is a very important result, and it will give a path to obtain the Laplace inverse of, I'll be taking it as 3, Laplace inverse of convolution between two functions. Sometimes they'll ask obtain a Laplace transformation of a convolution functions. Two functions will be given. Then how to calculate? We can take, because star means it is not any particular operation. It is just a convolution between these two, but it is not any particular operation. It is not like plus minus divided by into whatever it is. It is not like that. So you have to take it symbolically. The symbolic representation along with Laplace transformation will provide it's the result through f bar of s and g bar of s. Here we know how to obtain f bar of s as well as g bar of s, and its product will be our result. Okay, so here in this case we'll be taking one example to obtain or else to verify this convolution theorem. what it says. We can see we have been taken one example which says verify convolution theorem of the function. Two functions are given. One is f of t is equal to t and other one is g of t is equal to cos t. Then how to obtain these two, how to take these two results and how to obtain a convolution theorem. What convolution theorem says? Convolution theorem is this one. Fine. What I do, let us take the given thing as f of t is equal to t and g of t is equal to cos t. Okay. We have a convolution result which says Laplace inverse of f bar of s into g bar of s is equal to this. Fine. For that purpose, what I do, it is understood that we need f bar of s and g bar of s. So apply Laplace on both sides. Then it becomes L of f of t is equal to this is nothing but f bar of s, which will be equal to Laplace transform of t. Fine. Therefore, f bar of s is equal to Laplace transformation of t is what? Laplace transformation of t is 1 divided by s square. Fine. Similarly, apply Laplace on both sides, then Laplace transformation of g of t, that is nothing but Laplace transformation of cos t. Okay, so it indicates this is nothing but g bar of s, which will be equal to, what is Laplace transformation of cos t? S divided by s square plus 1. Fine. Then let us take Laplace transform convolution theorem. What convolution says? The convolution says Laplace inverse of f bar of s into g bar of s is equal to this. Okay. But when we are verifying, so what I do, I'll go to its basic definition part. Means we have not yet applied a Laplace on this, so we'll take this one. Okay, what is the difference between these two? Both are same, but here Laplace inverse is applied, here Laplace is not yet applied. So I'll be taking this result. Okay, as per that result, I'll write that result. Okay, so we know that f of t star g of t is equal to integration of f of u into g of t minus u with respect to u, where u is between 0 to t. Fine. Here what to do, this will be taken as f of t star g of t is equal to this. It is nothing but integration from u equal to 0 to t. F of u, you can see here we have f of t is equal to t. Then what will be f of u? U. Next, g of t minus u. What is g of t? G of t is cos t. Then what will be g of t minus u? That will be cos t minus u with respect to u. Then apply generalized Bernoulli rule. If you apply generalized Bernoulli rule, then we can simplify this result. Therefore, f of t star g of t is equal to, apply generalized Bernoulli rule for this. Then first function, integration of second function, integration of cos is sine of t minus u, sine of t minus u, okay, sine of t minus u. Okay, minus differentiation of first function 1, integration of this second function once again, that is cos of t minus u between u equal to 0 to t. Fine. Substitute upper and lower limits, then it will be equal to, if you substitute upper limit here, u is equal to upper limit u is equal to t, then it becomes t minus t will be 0, then sine 0 is 0, so it is gone 0, minus, if you substitute 0 in place of u, then it is again 0. Okay, then minus of minus plus, then substitute upper limit as t in place of u, then it becomes cos 0. Fine. Minus, if you substitute here, then it becomes cos t. Therefore, this is equal to, what is cos 0? 1 minus cos t. Cos t. Fine. So this is the result for f of t star g of t. Okay, one. Second point. Again, we will be applying Laplace on both sides. Then it becomes Laplace transformation of f of t star g of t is equal to. Then it becomes Laplace transformation of 1 minus Laplace transformation of cos t, which is equal to Laplace transformation of 1, that is 1 by s, minus Laplace transformation of cos t is what? S divided by s square plus 1. S divided by s square plus 1, which can be taken as 1 divided by, if you take its LCM, then it will be 1 divided by s into s square plus 1. Just check it out. S square plus 1. Fine. I'll be calling it as equation number 1. Similarly, we'll take f bar of s, because we have another result, f bar of s into g bar of s. Correct? Because Laplace transform of f of t into g of t must be equal to this. That is also verification. So f bar of s into g bar of s. Fine. So f bar of s is equal to 1 by s square into g bar of s is equal to s divided by s square plus 1. Therefore, s get cancelled. Then it is 1 divided by s into s square plus 1. So I'll be calling it as equation number 2. If you compare equation number 1